There are different ways to represent these aqueous reactions. What we've been looking at is the molecular equation. This shows the complete formulas for each compound as if they existed as molecules. So an example, 2KOH aqueous plus magnesium nitrate, MgNO3 aqueous, forming 2KNO3 aqueous plus MgOH2 solid. But if the KOH is dissolved in water, is it actually potassium ions and hydroxide ions right next to each other? No, they separated and they went off and dissociated, right? So we also have what's called a complete ionic equation that shows all of these species as they're actually present. And so anything like this that's aqueous, we would split these guys up and show that they are separated from each other. And then a net ionic equation only shows the species that actually change during the reaction. Some of these things, nothing happens to them. They were floating around in solution before, and they're still floating around in solution. Okay? And so those guys don't really matter. And so the net ionic equation is sort of the bottom line, what's actually changing. So when we're writing the complete ionic equation, we're going to write anything aqueous and ionic as ions. So that includes soluble salts. Remember, salt is a chemist's word for ionic compound. If it's an ionic compound that's soluble, we're going to separate it into ions. If it's a strong acid, we're going to separate it into ions. And we'll learn more about what are strong acids later. There's 6 of them. If it's not a strong acid, then it's a weak acid. There's 6 that are, and the rest aren't. And strong bases. If we have solids, liquids, or gases, we write those as molecules because they are not solubilized. They're not dissociated. We should memorize the strong acids, but we just haven't gotten to them yet. I'll give you a list. I'll write it on the board or something. Weak acids, remember what the difference between a weak acid and a strong acid? The weak acid only ionizes a little bit. And so most of it is in the molecular form. So for this complete ionic equation, we're writing it how most of it is. A strong acid dissociates into ions completely, and so we write it as ions. The weak acid doesn't do that very much. So for this example, lead nitrate is a soluble compound, soluble ionic compound. So we're going to show the lead ion and the nitrate ions separately. KCl is a soluble ionic compound, so we're going to separate those two into ions. These equations get really long. PbCl2 is a solid. That means it's a precipitate. It was insoluble. It does not separate into ions, and so we're going to show it in the complete ionic equation as this solid. We're going to keep it together. And then potassium and nitrate are soluble, and so we show those separated. If it's a solid, either on the right or the left, you leave it alone. So this is the way I think is good to think of it. If it's AQ, you're probably going to separate it into ions. If it's anything else, no. Solid, liquid, gas, no. Leave it alone. The only AQ ones that you do not separate are the weak acids. And we're not going to talk about those just yet, but they're coming. So the complete ionic equation shows everything, and the net ionic equation just shows the things that are actually changing. Some of the ions are not involved in the reaction, and we call them spectators. They're just watching. You go to a boxing match, and you watch 2 guys beat each other up. I don't think that's fun, but a lot of people think that's fun to watch 2 guys beat each other up. When everybody leaves, it's only the two guys that were in the ring that are messed up. The spectators are fine. They were just watching. Nothing happened to them. So in the net ionic equation, we're just concerned about the things that something happened to. And here we see that nitrate was floating around by itself before, and it's still floating around by itself. Nothing happened to it. It was just watching. It didn't become involved. Potassium was an ion floating around by itself, dissociated before, still dissociated afterwards. It's a little bit like in algebra, where if you've got, a plus x equals b plus a, you could just get rid of those a's, couldn't you? Because there's an a on the left and there's an a on the right. You could just subtract a from both sides and say, well, yeah, that's the same as x equals b. It's the same idea. So if it's the same on both sides, we can just cross it off. And what's left is the net ionic equation. So we don't include the spectator ions in the net ionic equation. We just write what's left. And so this tells us what actually happened. Lead 2 ions and chloride ions got together and formed a solid. Did the potassium have to be there for that to happen? No. Could have been sodium. The reaction would have proceeded exactly the same way. Example. Write the complete ionic and net equations for each of the following reactions. So we're being given the molecular equation. So complete ionic, we need to look at these things. If they're aqueous, we're probably going to divide them into ions. Are there any acids in this reaction at all? Anything that starts with H? No. So we don't have to worry about that. This is an ionic compound, aqueous. We're going to separate it into ions. There are 2 potassium ions. 2 K+. Now we should put aqueous here, but that gets really, really tedious. And the rest of it, sulfate, aqueous. Remember that ionic compounds have 2 kinds of ions. In all these sorts of equations that we're going to have you do, it's 2 ions. Do not separate this into potassium ions and sulfide ions and oxide ions. That's not what's happening here. The polyatomic ion, SO4, sulfate, stays together. And then here we have silver and nitrate. And this has a 2 in front of it. That means we've got 2 silver ions and 2 nitrate ions. Now you can do this without carrying those numbers down, but then you're going to have to balance the equation at the end. And I'd rather just carry the numbers around and then not have to balance it because it'll already be balanced. So there are the reactants. And then this goes to, which is, there's not going to be room, so we'll go down to the second line. This is aqueous, so this is potassium and nitrate. So 2K+ and 2 NO3-. And this one is a solid, so I'm going to leave him alone. Because silver and sulfate are really into each other. They're not mingling anymore. That's the complete ionic equation, showing all the ions. The net ionic equation is like your net paycheck after they take out the Medicare and the this and disability and the taxes, right? So that's the complete. And then we're going to get rid of the spectators. What's one of the spectators? Potassium. I heard someone whisper. It's a secret. What's another one? Nitrate. So what's left? We'll write those things down. We've got SO4 2 minus is aqueous, plus 2 silver ions, aqueous, forming silver sulfate, a solid. That's the net ionic equation. Net ionic equations are very useful for some things. Complete ionic equations usually are just a step in the middle. Molecular equations and net ionic equations are the ones that are more useful. But generally, to write the net ionic equation, you kind of have to at least mentally go through the complete ionic equation. Any questions? This is the kind of thing you need to do on the pre-lab for today's lab. It wants you to write molecular equations and complete ionic and net ionic equations. So we'll get some practice doing that. I'm going to skip that one.